Hey guys, and welcome back. Today we're talking about defining a function. So our learning target is just that, determine if a relation is a function. I'm going to highlight two things in that sentence because I believe there are two words in there that we may not know, and that's relation and function. Okay, and if you notice in our success criteria, I see the word relation written in every single one of them. I can identify a relation as a function from, and then we're going to be able to do that from a table, a graph, an equation, or a context. So first, let's define what a relation is. A relation is any set of ordered pairs. I'm going to highlight that word ordered pairs as well, and I'm going to put some synonyms next to it. Okay, an ordered pair is the same thing as saying point or coordinate. Okay, or even coordinate pair. So anytime you have a list of points, that is a relation. And we can split this relation into a table according to its inputs and outputs. Well, let's make sure we all understand what an input and an output is. Input represents our x values. Outputs represent our y values. And again, just as a reminder, that means our inputs are independent variables, and outputs are our dependent. Okay, so I can take all of these points that I have listed and I can actually feed them into the table by reading off all of the x values. Okay, so my x values that I see are 0, 1, 2, 3, and 4. So I'm going to write that in the input column. 0, 1, 2, 3, and 4. All of my outputs are going to be 0, 8, 16, 24, and 32. And so I've just created an input-output table from my relation. So now let's talk about how we can make these, or how we can define these relations as functions. A function is a rule for taking each input value and producing exactly one output value. Now, before I get to talking about these two tables, I'm going to make a quick sketch of what I'm talking about is a function. So when you say the word function, I want you to think of a machine. Try not to make fun of me too much for my drawing here. I'm going to draw what looks like almost like a juicer. Okay, so you have your input, and it goes into the machine. Okay, so something is happening inside of this machine. The way I'm drawing it, you can't really tell what's inside the machine, but something is happening when you feed something into the machine. And then I have to have somewhere to have output. So then something comes out. So think of like a juicer. If I were to put an orange, okay, so here's my lovely orange. Okay, if you can't tell, I'll even label it. That's an orange. Okay, if you put an orange into a juicer, then out will pop orange juice. So again, I'm going to show you my awesome artistic skills here. There's my lovely orange juice. So if you input an orange, out will pop orange juice. Okay, that would be an example of a function. Okay, we're going to use functions in a mathematic term where we input numbers and other numbers are their outputs. So let's take a look at this table. This is a function rule for taking each input value and producing exactly one output value. I want everybody to highlight that, point to it. It is the most important thing to write. Don't cross it out like that. Make sure you have a highlighter and not a black pen. Exactly one output value. That is the most important thing to remember about a function. Not just that any input has an output, but it's exactly one. Okay, only one output. Okay, if you have more than one output, then it's not considered a function. So let's take a look at these two tables. First, notice if you look at all the inputs in the function on the left, I don't see any repeating. -1, 0, 1, 2, and 3. None of those numbers repeat. So I can't say that any one input is assigned two outputs. But if you look at the function on the right, I see 3, 4, 5, 4, 10. That means the number 4 is being repeated, which means it has the potential of being assigned two different output values. And if we look, 4 is not only assigned to 7, but it's also assigned to 14. That means it is not a function because the input 4, if I make sure I can spell that, input 4 has two outputs. Okay, that's how we would write that in words. The input 4 has two outputs. That's a good reason, if you ever had to write that somewhere, as to why the function or the table on the left is not a function. So now let's take a look at the first example. This one says, is each relation a function, and explain. So I'm first going to make some notes on each table, and then in words, full sentence, I'm going to write how I knew one was a function or not. So the first thing I'm going to notice in A is that the input 1 has repeated itself. In fact, it is assigned to both outputs 3 and 2. So when I write this in words, I'm going to say this is not a function because the input 1 is assigned two different outputs. That is a perfect way to phrase why something is not a function. You can even reference what the outputs are. If you wanted to say two different outputs, 3 and 2, that would also be fine. But just stating that the input 1, being specific that it's 1 that's the problem, has two different outputs would be enough in this situation. Let's take a look at B and see if B is a function. So first, I don't see any repeating in the input column. -3, -2, -1, 0. So I really have no reason to think this is not a function. Now, what they're trying to do here is throw you off because the outputs are being repeated. When the outputs repeat, that means that doesn't mean that it's not a function. You can have outputs repeating and it still be a function because by definition, and I'm going to write that at the top, function definition is for every input there is only one output. Okay, now that means when I look at -3 only has the output of -5, so it's okay. -2 only has an output of -5. -1 only has an output of -5, okay? But the output -5 has multiple inputs. It's okay for outputs to have multiple inputs. It is not okay for an input to have multiple outputs. So I'm going to now explain that this is a function because every input has only one output. Now, I'm going to really emphasize that you say has only. That's really, really important because many students will often write because every input has an output, but every input will always have an output. I want a function to have no more than one output, so only one output. So B is definitely a function. Now when we look at C, I again am seeing no repeating in the input column. So just by seeing that there's no repeating, I can assume that none of the inputs are assigned to different outputs. So this again is a function. And I'm just going to repeat writing the definition because it's always good to repeat writing out the definition so that when you get to the test, you never forget it. So this is a function because every input has only one output. Now let's see how you guys give it a try. Okay, so let's take a look at the second example. It says use the vertical line test to determine if each graph represents a function. Let's talk about what this question is asking us. It references a test, a vertical line test. Okay, the vertical line test, let's write this down at the bottom of our page so that we have a note on what the vertical line test is. Vertical line test. Okay, this is when we test to see if any points lie on the same vertical line. So we are going to draw vertical lines and if more than 2 points lie on that vertical line, it is not a function. Because a vertical line is essentially all the same input with multiple outputs. So anything that is vertical is not a function. So we're really looking for points that are vertical of each other, not horizontal of each other, any points that are vertical of each other. And I do have a picture of a pencil down here. You can't just take a straight edge or a pencil, line it up vertically like this picture, and just run it from left to right across your graph to see if any of the points, any 2 or more points, intersect that pencil at one time. So if I were to run my pencil across letter A, at no point would the blue line ever cross the vertical line more than once. And I'll even draw some lines in here. If I drew a vertical line here, it only ever crosses once. If I draw a vertical line here, it only ever crosses once. Same over here, it only ever crosses once. Doesn't seem like there's anywhere on part A where if I drew a vertical line, it would cross more than once. So this is a function. Now let's take a look at B. If I were to draw a vertical line here, it only goes through 1 point. Here, 1 point. Here, 1 point. Here, 1 point. However, when I draw a vertical line over here, sorry, if I could draw a very good vertical line, see, and we're all human, we're not going to be able to draw a perfect vertical line without a ruler, but if I could draw a very perfect vertical line, I could see, and let me get rid of some of these lines here so your eyes can focus. If I drew a vertical line right here, these 2 points cross the one vertical line at the same time. So that one is not a function. And then lastly, part C, no matter where we would draw a vertical line here, it seems like no matter what, the blue line would ever only cross it once. That is called the vertical line test. We can do that on graphs to help us see if it is a function. So now let's see how you do it on your U-Try. All right, so I got one last example for us to be able to define what a function is. We still have yet to tackle if we're able to figure out if something is a function from an equation or a context, or that of a word problem. So let's keep in mind we can always ask ourselves the question, would any input generate two or more outputs? Because again, our definition for every input, there's only one output. So let's think about A. Y equals negative 3x. Now, you don't have to make a table every single time, but if you want to make a table of values to try to generate some points so that you can kind of guess if it's a function or not, I would just start with both negative and positive numbers, because where you're going to find something is not a function is if the positive and negative version of the same digit may be an answer. So let's start with -2, -1, 0, 1, and 2. Let's make a table. Well, this equation is saying you obtain the y's by taking the x's and multiplying them by -3. So -2 times -3 is +6. -1 times -3 is +3. 0 times -3 is 0. -3 times 1 is -3. And -3 times 2 is -6. Now, I created this table, so none of my inputs are going to repeat. Okay, but if I did repeat an input, is multiplying that input by -3 ever going to give me a different answer than what I've already written? No. So this definitely is a function. Okay, so I'm going to write that A is a function because for every input, there's ever only one output. If I were to make a table for the next one, again, I'm going to test the same kinds of points, positive and negative, -2, -1, 0, 1, and 2. Now, this equation is saying I need to take my input x, square it, and that's how I get my y. If you remember, squaring something means multiplying it by itself. So let's look at the x values. -2. Well, what's -2 times -2? That's +4. -1 times -1 is +1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is 4. Okay, now again, I set this up where the input values are not repeating. So far, it seems to be a function. Don't let that 4 repeating and the 1 repeating fool you. Again, it's only when inputs repeat that it's not a function. So this is still a function. Part C says, Miss Svetlik runs at a pace of 6 miles per hour. I think the easiest way to figure out if a context is a function is by creating the equation. The equation that we've learned how to create from contexts, the form, is y equals mx, where m is the slope or rate of change. So I'm seeing in this context, it says 6 miles per hour. That's how fast I'm supposedly running. Well, 6 miles per hour, that's the word per, so that means that's the multiplier or the slope. So my equation here is y equals 6x. If I were to create a table, I could generate some points, but again, if I were to just ask myself this question, would any input generate 2 or more outputs from this? Well, is multiplying something by 6 ever going to give us 2 different answers? No. No matter what I plug in, I'm going to multiply it by 6, and it's going to generate only one answer. If I plug in 3, I'm not going to get 2 different numbers just by multiplying it by 6. So part C is also a function. Now let's have you guys give this a try. Take a look at the 3 scenarios, and you can make a table if you'd like, or you can just try to ask yourself that question, which of these do you think are functions? All right, so that's just about it for us today. Please make sure that you review your learning target and success criteria. Your learning target today was that you could determine if a relation is a function. And by doing that, you should be able to identify if a relation is a function from a table, a graph, an equation, or a context. So if you need to reference these things, we were able to determine if something was a table from example 1, from a graph, example 2, and both the equation and the context from example 3. You can go back and reference those things. If you have any questions, please let me know. Thank you guys, and we'll see you tomorrow.